when I'm writing code, I like to think visually. So for me, it's really useful to draw out what's going on in my code. I like to visualize what's happening in memory and what the values, what the data structures that I'm working with actually look like in memory. So that brings me to this topic. What do JavaScript values actually look like? Right? If we were to visualize them, what do they actually look like? And I just want to add to this, I mean, in memory, right? What's happening under the hood? What do these values look like in memory? Let's take a quick look, okay? Now, before we actually get into the shapes that these values have, we have to make a quick distinction. A distinction between primitive values and the other ones, basically the complex values. Now, primitive values. So, why do we call these primitive values? It's because they are, I think the simplest way to define it is to say these are simpler values than the complex ones. So, when we talk about primitives, it's not because they're less powerful or less capable, but it's because they are simpler. So we're talking about things like numbers. We're talking about strings. So these are familiar types of data, right? Very familiar. We use these all the time. Booleans. There's a couple of others that also fall into this category, like the special values, the special constants, you could call them. Null, undefined. And if we want to be complete, if we want to really mention everything, there's two more, and they don't really, you don't have to know everything about them. They include the big int, which is short for big integer, and the symbol, but they aren't. These aren't values that you need to really know about, so don't worry about those. Now, complex values. Okay, yeah, complex values. Well, it's what's left. What's the rest? The rest is basically objects. But I'm also gonna write here. I'm gonna write arrays, and I'm gonna write functions, because those are also complex values. It's just that if you want to get technical, you can actually say that arrays are a kind of object and functions are a kind of object. But I'm just going to write all three here because they're all, I think we can make the distinction. They're all different types of values and they're all complex values. So now that we have that, well, we can look at what do primitive values look like. And luckily for us, primitive values are pretty simple. So if you imagine a little box that represents the value, then, well, if you have a number, I mean, it's pretty straightforward. We just have the value inside of that box. If we have a string, then it looks like this. If we have a string, it's just the value of that string in the box. Same thing with booleans. I mean, booleans can have true or false as their value. And null, for example, also, even though it's technically a constant, every instance of the value null is actually the same instance. It still looks the same. So that's it for simple values. They don't really have much more to them. So when we're talking about what values look like in memory, it gets interesting once we're talking about the complex values. That's where it gets interesting. So let's take a look at that. And we're going to start by looking at this first example, which is an array. So I have here a variable that I've defined that I'm calling colors. And I instantiate that with a value here. This is an array expression, right? It's an array expression with 3 items, 3 strings, it so happens. Now, when this expression gets evaluated, what happens in memory? What do we get as a result of this in memory? How does that look like? What does an array look like in memory? Now, I like to use something that I kind of personally call a little ladder drawing. Why? Because it actually looks like a ladder. And I draw it like this. Now, before we go further, I'll say that, well, you could draw an array sideways as well. Why not? You can draw it however you like. In memory, these values don't actually have a kind of an orientation in space because memory doesn't work like that. Memory is linear. It's just a straight line, basically, as far as memory is concerned. Everything is just linear. But, well, it's easier for us if we draw it as something that seems familiar. So an array ladder diagram looks like this. And, well, the values that we have here, well, they go into the little boxes that I drew. Maybe I should have drawn this a little bit bigger. But what else does an array have? Well, it has the values arranged one after the other. And then it has the index. So let me just draw that here. Let me specify that what we have is an index and we have the value. And together, this is how I like to look at it, together these make up what we call an array item. So every item has an index and every item has a value. That's pretty straightforward, okay? So arrays are straightforward. They're just a list of items, and each item, yeah, we know that we can use the index to access those items. Now, what happens if you add something more to this array? Well, simply enough, we're going to add another item, which is going to have its corresponding index like that. If we had drawn it sideways, we could have done that too. But I like to draw it like this, like a little ladder. That's great. So that's what an array looks like. That's how I like to imagine an array in memory. Let's look at another example. What is this? Well, here I am defining a variable called person. And what is the value here? Well, it's actually an object. We're creating an object. It's an object literal expression. And so when this expression gets evaluated, we're going to have an object that's going to get created in memory, right? So what is that going to look like? What does an object look like in memory? Now, the cool thing is that I think we can actually reuse the little ladder diagram. To make things look consistent, we're going to draw something that looks similar, but I'm going to make it wider. I'm going to make it wider because there's now a little bit more. There is now, well, actually kind of two columns. So an object is actually, instead of a list of items, it's a list of what we might call properties. This is one property, right? Just this row. And if we look at this example, well, what does the property have? It has a name. The name is name. The second name is age. And then the third name here is city. And as for the values, we have this property has a value here, which is a string. The next one has a value that happens to be a number, and the final one is another string. So what these columns are, well, each property actually has two parts that we just saw. It has a name, and you might say that the fuller phrase for this, the complete phrase would be to call that the property name, and it has a value. So the value is the property value. Well, it's similar to what we saw in the array. So there's a similarity here. You could say that an object almost looks like an array, but where instead of indexes, right, in the array, let's look at it again. On the left, what we have on the left is a series of indexes. In the object, it's kind of similar, except instead of an index, which is just a number, we have a name, a property name. And on the right, well, we have value, which is the same thing as an array. Now, differences between an object and an array, well, it doesn't exactly work the same way when you're adding or removing properties. Um, in other words, with an array, you can add another item at the end and it automatically gets an index of its own. But with an object, you basically have to give it a property name before it can be added to the object. So that's a distinction. But in memory, well, they kind of look a little bit similar. And we also know that in terms of syntax, if I were to use this value here, which I called person, then one way that I could access the properties is to use the bracket notation, specifically the square bracket notation. Give it the property name that I want to access, and then this will evaluate to the value that I'm looking for. In other words, this property here. And I mean, if you use arrays, then you might realize for our array that we call the colors, there is a similarity in how we access them. We use the same kind of access, where if we want to get color at index 2, we also use square brackets. So that is how I imagine arrays and objects when I think about them in memory. And it's really useful to have that in your mind when you're working with these kinds of values. Why? Because it helps you visualize what's going on when you're manipulating these data structures. When you're adding, removing items, when you're manipulating the properties. And it's also useful to me. It's always also useful to have the right names. For example, calling this property, it's useful to be able to refer to this whole row as a property. And then, we then end up with the ability to call, this left column, the property name, and the right column, the property value, which is useful when you're getting deep into it, right? Like when you're getting deep into the code, and especially I would say when you're discussing with coworkers, with collaborators, when you're discussing the data that you're manipulating, it's really useful to be able to very clearly talk about what parts of the data that you're talking about. And one of my favorite techniques is to get together in a room and use a whiteboard. Okay, so it's a really powerful planning technique if you are working with people and you have to discuss some code. Don't just look at the code. My advice is also look at what ways you can visualize it by just drawing on a whiteboard. I mean, it's a really, really powerful technique to help get everyone on the same page and to help move the discussion forward.